All right, so we are going to talk about right angle trig today, and the question that I asked is, what if a triangle isn't on the unit circle? What we've done so far as finding values of sine, cosine, tangent, cosecant, secant, and cotangent is all angles that are on the unit circle or have a coterminal angle on the unit circle. But what if you're given an angle that's not on the unit circle? Or what if you don't know the angle? So, if you don't know the angle's not in the unit circle, it's okay. You can fall back on the definition of trig in these ratios, which is SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So those are the basic trig ratios and how they're defined. These are all reciprocal functions of these, so if I want to know cosecant, I'll just flip and do hypotenuse over opposite, hypotenuse over adjacent, and adjacent over opposite. That is easy ways to get these last three from these first three. Reciprocal identities, these are other ways to think about it. The sine is actually the flip of this, cosecant's the flip of this. So these are other ways to think about it. So the example that I have is sketch a right triangle corresponding to the trigonometric function of the acute angle theta. So in this one we don't know what the angle is, so it's just noted as a theta. And it says sketch a right triangle, so you can sketch any right triangle. It says use Pythagorean theorem to find the missing side and find the 5 other trig functions. So if I know that tan of theta is 3 over 4, I have to mark one of the angles as theta. You can do either one, but I'm going to pick this one. If I know that tangent of theta is 3 over 4, I look at the formula, tangent is opposite over adjacent. So then I know 3 is my opposite side and 4 is my adjacent side. It gives me ratio of those, and so the opposite side is 3, the adjacent side is 4. I can use Pythagorean theorem, or I can just see this is a 3, 4, 5 triangle because it's a Pythagorean triple, and that's the hypotenuse side. Now I can go through, use all my formulas, figure out all the rest of them using these numbers. So sine of theta, opposite over hypotenuse, 3 over 5, cosine of theta, adjacent over hypotenuse, 4 over 5, tangent we have, cosecant of theta, hypotenuse over opposite, 5 over 3, secant of theta, hypotenuse over adjacent, 5 over 4, and cotangent of theta, adjacent over opposite, 4 over 3.